Hi, in this video, I want to talk about the rational function and some important characteristics. The first thing I want to talk about is how we can find the x and y-intercept of any graph. So anytime we are asked for an x-intercept, that means that y has to equal to 0. So if we are giving an equation, and we can do this for any equation we're given, all we need to do to find the x-intercept is plug in the 0 for y. So where is y? Y is the same as f of x. So I'm going to go ahead and plug in 0 and see what we get for x. So if I plug in 0 for y, we will have 0 equals to 4 over x plus 3 minus 2. And from here, it's just a multi-step equation. So we want to isolate our x variable. We're going to add 2 onto both sides. And this will cancel here. And on the left, we will have 2 and then is equal to 4 over x plus 3. We can cross multiply. So this is the same as 2 over 1. Cross multiply, what I mean is we can multiply the 2 with the x times x plus 3, and we can multiply the 4 and the 1. So that will give us 4. And then when we simplify that, we will distribute and get 2x plus 6 equals 4. Subtract 6 on both sides. We get 2x equals negative 2. And then divide by 2 on both sides, and x equals to negative 1. So basically, we just found that the x-intercept is negative 1, and that is, of course, when y equal to 0, when we plug into this equation. So let's go ahead and make a table and do the same thing for y. So our x-intercept is when y is 0, x is negative 1. Let's go ahead and find our y-intercept, where our y-intercept is going to be when we plug in 0 for x. So I'm going to plug in 0 for x, and I'm going to go ahead and plug in the 0 into this x value. So when we find our y-intercept, we're going to say y equals to 4 over 0 plus 3 minus 2. And then we're just going to go ahead and simplify that. That is equal to 4 over 3 minus 2. Now, I don't mind if you use a calculator to find this out, but you can easily just convert the 2 into a fraction. So this is the same as 2 over 1. We want to have the same common denominator. So multiply the bottom here by 3 and the top by 3. So negative 2 is actually the same as negative 6 over 3. So our y-intercept is negative 2 over 3. So when x is 0, y is negative 2 over 3. All right, so we have our x and y-intercepts for this graph. And as I mentioned before, anytime you want an x-intercept, you plug in 0 for y into the equation. If you want a y-intercept, you plug in 0 for x. So here's our x and y-intercept. And let's go ahead to see what else we would like to find out. We want to know what our vertical asymptote is for this graph. Well, as I mentioned in previous videos, a vertical asymptote is you need to look at the denominator, and whatever would make the denominator 0 is going to basically be your vertical asymptote. So you can actually just say x plus 3 equals to 0 right here. X plus 3 equals to 0. Subtract 3 on both sides. So our vertical asymptote is x equals to negative 3. What is our horizontal asymptote? Our horizontal asymptote is our k value right here. So if I go back, our vertical asymptote happens to be our h. So if we apply the same knowledge as we did for the denominator, if I said x minus h equals to 0, then x equals h is always going to be our vertical asymptote. And our horizontal asymptote since this fraction can never be 0, that means our horizontal asymptote is going to be right here, y equals to k. So y equals to k is, I'm going to call this h dot a for horizontal asymptote, and x equals to h is a vertical asymptote. Okay, now this is important because this will help us find the domain and range. So if we're looking at the domain is the set of all possible inputs for x values. So the x can be anything. I could enter anything we want except, let's look at here. I could enter x to have any value except whatever would make this denominator 0. So if you look at the denominator, x plus 3, there's only one value right now that would make this whole denominator 0, and that is if x equals to -3, which is our vertical asymptote. So our domain, therefore, is x is a set of all real numbers where x cannot equal to -3. And our range is y is a set of all real numbers. Remember, range is of all outputs, all possible outputs. Y is an element of all real numbers where y cannot equal to -2. Now, how would we describe the transformation? Well, basically, I don't even need to draw the graph yet to describe the transformation. I can look at my vertical and horizontal asymptote. So basically, if you recall, the h is going to move your graph left to right. Anything to do with x moves your graph left to right, and your k will be vertical, in other words, up or down. So in this case, the transformation, how would we get +3? Well, if x was -3, so our horizontal transformation is 3 left. So we would say 3 left, and our vertical transformation is 2 down. So we will say 2 down. All right, so we have all our characteristics. We have a vertical asymptote at x equals -3. We have a horizontal asymptote at y equals to -2. We have the domain as x is an element of all real numbers where x cannot equal to -3. We have a range where y is an element of all real numbers where y cannot equal to -2. The transformation is 3 left and 2 down. We have an x and y intercept at these values. And if we made a quick sketch using these characteristics, well, the first thing I would want to do is I would want to draw in my vertical asymptote. So at -3, we have a dashed line. Okay, that means the graph will not be able to touch -3. We also have a horizontal asymptote right here at -2. So the graph will approach -2, but it will never touch -2. We have an x-intercept at -1, 0. So we can say it's somewhere around here is -1. And we have a y-intercept at 0, -2/3. So somewhere here. Now, to sketch the graph, this is a sketch. It's not exact. I'm going to go through my 2 points and towards the vertical and horizontal asymptote. And then on the left side, if you wanted to know exactly where to put 1 point at least, well, all you need to do is go left of -3. If I move 1 over, let's say -4, and I plugged in -4 here, well, what would we get? -4 plus 3 is -1. 4 over -1 is -4. And -4, -2 is -6. So actually, when x is -4, we have y is -6. So we can add that to our table. And we can put that point somewhere here. So therefore, our graph is going to be going towards our asymptote. I know this looks a little crowded here, but it's going to go towards our asymptote and then curve. So there is our quick sketch. with our characteristics, our x and y intercepts, transformation, domain range, vertical and horizontal asymptotes.